Just started. Hang on. Oh, whoops. Okay. Well, maybe. Come on. Oh, cute. There. Make sure we share the desktop. Where's my mouse? There's somewhere, hopefully. Come on. Technical difficulties. Well, my mouse decides to die, so okay. Well, Angel, go ahead. We'll go with it.
So hi, I'm Angela. I currently have an internship at Cisco. So just a couple of facts about Cisco. It was founded in 1984 by Leonard Bosak. It's headquartered in San Jose, California. They actually flew me down there for orientation, and there's like a Cisco Way, a street named after Cisco. It's amazing how much presence they have down there. Their name's derived from San Francisco. The logo is the Golden Gate Bridge. One of the first companies to sell commercially successful routers that supported multiple network protocols. So this is before, the dominance of IP that we have now. It was the most valuable company in the world in March of 2000, and it's still pretty valuable today. The revenue is greater than 40 billion a year. The server group, of which I am a part, contributes 4 billion a year to that figure. And 80%, it's estimated that 80% of all internet traffic goes through Cisco products. So right now I have a pretty flexible schedule. I work a 40-hour work week, but they're really flexible about when I come in and when I leave. I have about a 2-hour window when I can show up, which is really helpful. There's no overtime. I make $19.75 an hour, but I also got a $6,000 sign-on bonus, which was pretty awesome. And I also get 6.16 hours of PTO accrued each pay period. So that's really nice as well. That's how much regular employees make that have been working there for years. So it's a pretty nice deal. There's free snacks, coffee, tea, and Pepsi. They have a small budget. They go to Costco and buy things. It's pretty much different every week, although we get like little granola bars. It's breakfast every morning. So here's me, actually, that picture right there is me down in San Jose. So like I said, I had a paid visit to San Jose for orientation. Lunch and dinner was provided. We went out to Dave & Buster's as like a team building group activity, which was pretty fun. It was for 3 days, 2 nights. They put me up at the Hilton, which is quite nice. The Hilton has free drinks during happy hour, it was nice. Anyway, also went out and tried Spanish food for the first time. I hadn't really even thought about Spanish food. It was very good though. And then we had this Cisco Rocks thing, which is like, I don't know, like a company picnic type thing. Happens once a year, I think. But we had lunch at the McMinimans Grand Lodge, which is pretty nice. We played some Frisbee golf together. If you're into Frisbee golf, the course is okay, but what's really nice is you get to throw a disc off a second story, which is definitely experience to try.
It's like a starting point?
It's not a starting point, it's the last hole.
Okay.
Cool.
Yeah, well, sorry, I meant, yes, that's where you tee off from.
Oh, okay.
Sorry.
That makes more sense.
Yeah.
I was like, wait, so you throw it up and then you have to throw it off the building?
No, that would be pretty cool though. Anyway, so then here's the organizational structure. That's my manager, Jack. And then there's myself and then another intern, Michael. And then Bill over there is down in San Jose. He works on a different spot, and I work with his employee, Josh, with implementing some on that type of server product. There's racks and there's blades. The group that I work with work on servers, but Josh does rack servers, and I've done a couple of user level devices for him. And then over here are the guys who are in my office. Kevin's the technical lead. Jason is really good with DIMMs and LEDs, which is what I've primarily worked on so far. Fernandra, I'm working on bringing up the solution that I'm working on. So he's somebody that I go to and ask, how is this part of the software supposed to work so that I can do this? I haven't really worked with David quite yet, but I'm going to be able to assign him some things in the future. Jared is also working in conjunction with Fernandra to make the base of the application that we're working on. And then Scott is my mentor.
Are you the only woman in the group?
There is one other, which is, okay, I guess. It's actually pretty funny. I guess we're practicing for a while before I joined on how to appropriately treat the interns. Sorry. So here's a server comparison. Like I said, Josh works on racks and we work on blades. So the blade server, it sits in a chassis, and there's like a couple of different slots that you can slide in the blade server into the chassis that's got 4 full width slots for a blade server. And it requires that UCS infrastructure. It only connects to the UCS Fabric Interconnect, and it's managed by UCS Manager. Just some other things. But the rack servers, they're just a rack. There's no plug and play to that. They come as a solution. You don't add servers to it. And it doesn't require the UCS infrastructure. It can connect to any Ethernet switch. It doesn't require the Fabric Interconnect. And then it has a lot of other supports for different sort of devices that the blade servers don't have. So 2 very different products. So what I'm working on, when I was talking about Fernandra and Jared working on the application we're working on is called IPMI, which is Intelligent Platform Management Interface. So it's a specification provided by Intel. There's a lot of different implementations of the specification. There's actually an open IPMI that you can download and look at if you're interested. It's used by Cisco in both blade and rack servers. It essentially monitors hardware. It keeps a list of the hardware inventory so it knows what's plugged in, what the temperature readings are, things like that. And it also provides logging. So like, let's say that the temperature spikes really high. I want to know about that. And maybe I want to turn that component off or do something else. So this is what monitors that so that those sort of decisions can be made. And it also recovers and restarts the server when it deems it to be necessary. Mm-hmm. So that's as far as what I'm working on. And when I make devices, yeah. So one of the devices that I made is, it's called the dummy interface. It's interface defined by IPMI tool, which is an open source tool that's provided, by the community to talk to IPMI. And so this is just the dummy interface, a way for information to be exchanged. And so it converts the data received from the dummy interface into an IPMI message, which is how the system understands things to work. And the message is parsed by the IPMI software, and then a response is generated, and then it converts that back into the same format that the IPMI dummy interface understands. So another project that I've worked on is a code generator, and this is actually pretty cool. I like writing code to write code. So essentially what we have is a sensor data record, and if you want, you can look it up in the specification provided by Intel. But it's just basically there's fields that say, this is the maximum limit for this particular device. If it goes over this, tell me about it because I want to know. These are how to interpret the readings, like maybe it's not, it's discrete to where you have to have some sort of formula to understand what the reading is. Just things like that, information about the sensor. It's stored in a text document for us, but we need to read that text document and create structures for it in the application. So it does that for us based on the information in the text document. And so, yeah, I use Python to generate the code for it. And then it happens automatically via the use of Makefile. So like there's parent Makefile, and then it checks to see in the platform specific if a Makefile exists. And if it does, it calls that Makefile, and that Makefile does whatever it is that the platform needs.
Mm-hmm.
And so that's another thing that I've been working on, just various different devices. So each sensor has a device associated with it. I've implemented several devices. I've been working with DIMMs a lot. I've implemented the DIMM presence, temperature now, and I'm working on ECC to make sure that the DIMMs are happy, they're inoperable before trying to use them. The virtual card presence, so that's basically like an Ethernet card. That's something that the rack servers use. So just telling whether or not that Ethernet card is plugged in. Fan speed, some LEDs. The LED alert is like a cluster sensor. It manages the health of all of this, or monitors the health of all of the sensors. And if something goes bad, it like blinks. Things like that. Okay. So this is what actually manages it. There's like a process, a sensor that does that reading, and then there's another LED that actually blinks based off that reading. So it just knows how to interpret the reading and do things. Yeah. So like I said, I developed the architecture, or for this, I developed the architecture. It was a little bit unclear at the time whether this was an LED or something a little bit different. And so I had to go and make the argument that it wasn't necessarily an LED, it was a cluster sensor, and it does do other things that we need to know about. So tying it so tightly to the concept of LED isn't really appropriate, because if it didn't have an LED, we'd still need it to run. So helpful courses. The 407 threaded and parallel programming, we do a little bit of threading, so that's very helpful. Operating systems, Unix. I do all of my work in C, in straight C. I don't even remember what an object is anymore. So the first two C programming ones, computer organization and introduction to digital logic, because I do a lot of stuff with hex. I read a lot of like data sheets, so I can figure out what registers to write to, things of that nature. So yeah, like I said, I learned how to read a data sheet to implement devices. So that's a pretty cool skill. I learned what IPMI is and how to, and what can be done with it, because I'd never heard of it before. The importance of following coding style guidelines. My one of the people at my work is very strict about it. I actually, in one of my code reviews, neglected to put the correct amount of spaces, and that was filed as a bug. But it is really important, because I've looked at some previous versions that were more of the Wild West, and it's almost impossible to follow without proper intention where things stop and start. And I think a lot of bugs get introduced that way, so it is very important. The difference between C and C++. If you haven't used C extensively, you might think that they're kind of the same thing. They're not. How to communicate with Linux kernel drivers. One of the things that I'm working on right now is, it's called Tulip. It's a network driver, kernel driver for Linux. And so that's been pretty interesting. How to write makefiles and Python. I've never used it before. And then my overall impression, it's a fun, relaxed place to work. We have a foosball table. People use it daily. Everybody's really nice. They're supportive and helpful. I can ask questions whenever I want. And that they're willing to to sit down with me and make sure I understand it. They have a major focus on software security and quality. You know, Cisco is a pretty big brand. It's world recognized, and so a lot of people use it, and it's something that's that notoriety makes it a target for hackers. And so we actually have like security courses that we need to take so that we understand what hackers can do to our code to gain access that they're not supposed to. And that structured architecture is very different than object-oriented architecture. The whole world is a lot different. It's a different hat that you have to wear when you do structured programming. So this is my second internship. My previous internship was at Intel. So I'm just going to do a quick comparison over that. Intel's main campus is in Hillsborough, while Cisco in Oregon is in the unique position of being a small office within a large company. So that allowed me to get to know all of my coworkers, which would have been impossible at Intel. And I'm sure it would have been impossible in San Jose with Cisco as well. But it's more like we're kind of a startup with a big company behind us. It's pretty nice. Well, I worked in a department that dealt with hardware at Intel. I spent most of my time using high-level languages to provide reports and other support to that hardware group. At Cisco, I'm using C-to-write devices, and as I said, that's a very different hat to wear. And then also, during the entirety of my Mecop internship at Intel, there was only one other person who had studied in a computer science-related field. And they were actually a computer engineer. In my whole group, the rest of them were all electrical engineers, so there wasn't a lot of the support that I have at Cisco. So like I said, there's 5 people that I work with on a regular basis who studied in a related field, and at least 10 people who would be more than happy to answer my questions at any time. So that's my spiel. Any questions?
Would you do it over again? The same way?
Yeah, I think so. Yeah.
Okay.
So you are computer science student.
Yeah, I'm software engineering, but yeah, there's a pretty big difference even between those two things.
But not embedded systems,
No, not embedded.
but doing embedded work, kind of.
Yeah. Yeah. No, and I think that
Not totally embedded, but
the program here with the computer architecture prepares you. I mean, not as well, obviously, as an embedded engineer, but with the level of support I have, I feel pretty comfortable with what I'm doing.
Do you hope one of these places will hire you, or do you want to go somewhere else?
They've both offered to hire me.
Oh.
So, yeah.
But I mean, is that what you want? I mean,
I kind of want to work at Intel. I really liked working in a higher level language. I'm not as happy working in a lower level very well. It's nothing, like I said, my office is great, but it's just not the hat for me. So, but they're gonna, I'm gonna have a meeting with the vice president of engineering, and we're gonna see what else might fit for me at Cisco. Anyway, any other questions?
All right, thank you. Thank you, Angela, for coming. Appreciate it. Okay, thank you. Okay, all right. Dylan.
so you're going to post these
Well,
slides?
if slides, yeah, I can post the slides.
I'm about to pull mine up on email or
Oh,
something.
okay. My mouse kind of died. I don't know if it could or not. Just my mouse like is frozen at the moment. I don't know why I could. Yeah, so my mouse is frozen.
Well,
Does everybody have
a lot of tabs is what's going to be required.
tabs?
All right. Laptop.
Or die too?
No, it's just, it's not pop. The app's not popping up.
Oh. No, I can.
Here we go.
Oh. Is the mouse back?
No. Oh, yeah, that's a good idea.
It's gonna kill me, but that's okay. Although somebody has a mouse.
I did, I just took it out of my backpack this morning.
Yeah.
I literally like I needed to put new batteries in it, and I put new batteries in and didn't put it back in.
Try to steal a mouse out of this laptop. Well, actually. Machine here. Check the instructors. See if you can pull the mouse out of the instructors here. Wireless? You got that wireless? Oh, okay. Can try that.
You got wireless mouse?
Okay. All right. There's another slot there. Thank you. Thank you, Erin. Okay. Oh, yay. Okay. There you go.
Windows
Sign you out.
Send me out.
Yeah, exactly.
Windows 7 takes
Okay, let me
Windows
actually
7 is
post
nothing like Windows
the
7.
Hangout session before you send me out.
Did you just say Windows 7 is nothing like Windows 7?
No, Windows 7 just is nothing